So today we will start with alternating current. We have finished EMI completely. We will start alternating current, right? Have we discussed something in alternating current? Yeah, so we will start chapter 7, that is alternating current. Alternating current or AC. So basically, we know that AC means changing current, right? AC means current which is changing with passage of time. May change sinusoidally. So alternating current means current changing with time. The kind of, we may have sinusoidal variation, we may have kind of other variations also. So generally we take, for alternating current, generally we take sinusoidal variation. Like this. Generally we take alternating current variance. So we can write the equation of alternating current like I is equal to I naught sine omega t, or I is equal to I naught cos omega t, kind of that. We can also take alternating voltage. Alternating voltage can be represented like V is equal to V naught sine omega t, or V is equal to V naught cos omega t, kind of. So we can have that kind of equations for alternating current. Now the first thing which comes during alternating current, which we have to calculate in the. So Rifat, you are preparing for NEET. I think you are preparing for JEE, right? Yes. So sometimes we know that like we have formula for. So first we generally define RMS value, like RMS value of voltage or RMS value of current. So we'll start with RMS value. First, let us start with average value. Average value we all know. Then we will start. So average value of current. So we know that generally what happens in average value, that when you take average value of a AC, generally it comes out to be zero. That is why RMS value was needed. Why we need RMS value? The reason behind is that when you have a AC current like this, sinusoidal varying current. So what happens when you take average value over a time period, it becomes zero. So that is why for alternating current, RMS value is needed. So how we define average value? Any kind of average value, if you want to take average value of current, we define it like that. I dt divided by dt. If you want to calculate average value of anything, you can apply this formula. For average value of voltage, or for average value of voltage, or for V average, you can write it like that, VDP divided by dt. So this is the basic method to calculate average value of anything. So if you see here, for sinusoidal current, if you take in full cycle, it comes out to be zero. If you take here for the full cycle, it comes out to be zero here. For sinusoidal, I is equal to I naught sin wave. So actually the current is varying, right? So if you want to calculate something, you will need some kind of constant value. So, and if you take the average value of your alternating current is zero. That is why RMS value is needed. So now we will see RMS value. So what is RMS means? RMS means root mean square value. Root mean square. Root mean square value. Root mean square value. RMS value root mean square. So the basic funda, or the basic concept behind it, how do you remember to calculate RMS value? I will suggest you to go back, to go from forward direction to back direction. Then you can understand it better. Actually, what does it mean? You have to take square value, then you take mean of that, then you take root of that. That is RMS. For example, how to calculate IRMS? You can understand that. First, you have to square value like I square, then take mean. So we have taken I squared dt by dt, then take root. That is the RMS value. What my point? Like you can also like IRMS is equal to I1 square plus I2 square. If the values are discrete, I3 square by 3. So this is the RMS value. What you have to take? Square the value, take the mean, then take the root. That is RMS. Getting my point? Understood? So this is how we calculate RMS value. So if you calculate, I'm not going into more derivations and all. We will directly do the question. That will be better. So for I is equal to I naught sin omega t, when you will calculate the value, you will get I RMS y will be equal to I naught by root 2. Similarly, if you have voltage like V is equal to V naught sin omega t, we will get V RMS equal to V naught by like that. So now we will directly jump to the some questions so that we can do the question based on RMS and annual value. Then we will do lot of more discussions. Now see question number 5 and the question number 6. Attempt you both attempt both the question number 5 and question number 6. For 5 you got D. Now calculate for 6. 5 I will explain. First calculate 6. For 6 you got C. So let us check for 6. 5 I will explain. Let us see. Here you have to go for general formula. What is VRMS formula? VRMS is V squared dt by dt under root. Now you have to see, you have to take for one time period. So like VRMS square, that will be equal to V square dt. I will take time from 0 to t. Now we can calculate RMS square. That is MEA square. Can you see the screen before? B square dt divided by total time is obviously t. So now we have to take the value. B square is 0 between t2 and t, so 0 say 0 to t by 2. The value is v naught square by t. We will get it as take v naught square formula. So we get t by 2 divided by 2 t, so we will get v naught square 2 divided by t. So we get v naught square. So we got RMS square equal to square 2 to VR. You know, but it, yes, your answer was correct. But fortunately, that I think we have directly applied that formula. But here, if we have to do it like this, here fortunately comes the same value, but we have to apply this. Getting my point? Five question really will need you to know the value of capacitance XC. You know what is the value of capacitive reaction? 1 by omega c, right? So from there you can do that. That is why actually we will discuss it. We know that how to calculate RMS, IRMS, and VRMS. Yes, it's correct. IRMS by VRMS by. So VRMS is given in the question. RMS will be not by 2 is 1 by omega c. So in the question, what is V naught? But in basically 200 root 2. So 200 root 2 divided by omega. What is omega? Omega is 100. And 100 e to 1 by 6. X X 2 yes, we can see. Your answer was correct. You have given 20 km, right? Have you calculated in the same way? Have you done like into the next question? Nine question you can easily do that. The RMS is I not by some JEE questions based on that. RMS value generally take no task. Direct questions are asked for marks. question I'm not gonna directly from. So let us now we have seen what is AC alternating current. We have seen. Now we will see the now will we now we will know the behavior of alternating current with different circuits. How this alternating current behaves. But purely capacitive circuit, purely active circuit, purely resistive circuit. So we're gonna see that. So let us see. AC first will be AC applied. Purely resistive. First we will see that. To suppose we have used alternating current. Suppose alternating voltage V is to not resistor R. So easily here we can see that the current will be I will be considering. Where I not is the peak value of current. So in purely resistive circuit, actually we can simply apply Ohm's law and calculate the current. And if you draw the phasor diagram and all, you can see current and voltage are in same phase, right? If you draw voltage and current diagram, that is like, so if it is like voltage and current same phase with the voltage, the current like just the current will be less than is what that will be the same page. So current and voltage variation will be same fashion. They are in same phase. If you draw the phasor diagram, how we draw the phasor diagram, then only we like, take the voltage. So the current will also be in the same phase with the voltage. Value will be little less, but same phase with the voltage and current are in the same phase. diagram. See my point? Voltage and current are in same. So for every kind of circuit, we do analyze this way. We draw first, we apply the given AC to the circuit, then we write the expression. So I'm not going to write for every circuit. I will just write the expression of voltage and current, and I will tell you that in this circuit current is leading or in this circuit voltage. Getting my point? I'm not going. You have already studied in different class of figure diagram and in competition, no question is asked with figure diagram. You directly write the expression. Got it? So similarly, if you apply voltage AC to purely resistive circuit, to purely capacitive circuit, purely capacitive circuit, in that case, what will happen? If you apply voltage to circuit, in that case, what will happen? You will get current is equal to I naught sin omega t plus phi. Current will lag. You have to remember that in capacitor current always lags. Current leads. In capacitor, C for capacitor, C for current. So only remember that in capacitor current is leading. Getting my point? And in inductor, current will lag. Got my point? So always remember in capacitor, C for capacitor, C for current. In capacitor, current leads, and it is reverse in inductor. In inductor, current will lag. So you can see AC applied to purely inductor circuit, AC applied purely inductive circuit. That is what will happen. Here what will happen? Current will lag, right? It will here I not will be equal to IRMS. What is excellent? Then you may know that Excel is equal to A by equal to here also 5 to 5 and if understood, the RMS is equal to the RMS, right? This is how we can. Similarly, we may have like LR circuit, and we can have LR circuit and RC circuit. In that case also, like you can have RC circuit and you can have LR circuit. In RC circuit, you have resistor and capacitor. In the same fashion, here what we will do, we recognize, suppose V is equal to voltage is equal to V naught sin omega t. Obviously, in RC circuit, current will lead or lag. In RC circuit, current will lead or lag. I am asking in RC circuit. In capacitive circuit, always current leads. What I told you, in capacitor, current always lead. In RC circuit, also current will lead. In LR circuit, current will lag. Capacitive circuit, always current leads. C for capacitor, C for current. Getting my point? Whether it is purely capacitive circuit or RC circuit, current will lead in both the cases. And where it is purely inductive or RL circuit, current will lag. Getting my point? So current will lead or lag in RC circuit. Tell me again, current will lead or lag in RC circuit. Correct. So here what we can write, in purely capacitive, you add pi by 2. Here what we will do, we will write it like that. I is equal to I naught, but plus pi, where cos phi is R upon Z. What is Z? That is R square plus XC. Similarly, in R circuit, voltage is equal to, we can write current is I is equal to I naught. Current will lead or lag in LR circuit. And you are telling me what I have explained to you. I am asking in inductive circuit, LR circuit. LR circuit, current will lead or lag. Asking you if in LR circuit, current will lead or lag. So lag, na? If it is in capacitive circuit, it is leading. In LR circuit, opposite happens. Only one thing you have to remember, in capacitive circuit, current leads. So in inductor, it will lag. Simple. It will be minus pi, where cos pi is equal to R by. That will be R square plus XL square. cos phi will be r by r square. The current will lag. So what you have to do, just write the expression. You can calculate I naught. How we can calculate I naught? I naught we can calculate. I naught will be equal to V naught by Z. Also we can calculate I naught. Got it? Understood? Now we have a formula that is for power. So average power, average power. P average is given by PRMS, PRMS, IRMS cos. Average power of AC circuit is given by PRMS, IRMS cos. This is the average power. Nothing is mentioned in the question. It means you have to calculate everything. Got it? So based on these formulas and concepts, we will do some questions. Now we can do the questions. These are AC circuit. So now try question number 7. Question number 7. So you're getting C. So very simple thing. I think your answer is correct. So the same formula we have to apply. ERMS, average power. So P average is equal to VRMS, IRMS, cos phi. Here there is a printing mistake. F means phi. This is actually phi. So we know that VRMS is V naught by root 2. IRMS, we know that IRMS is equal to I naught by root 2 cos phi. So in the question it is given as E naught. So E naught I naught by 2 cos phi. C is the correct answer. Got it? Moving to the next question. Now to the question number 17. And question number 17. Okay, it says a series RC circuit is connected to an alternating voltage source. Consider two situations: when capacitor is air filled, when the capacitor is mica filled. Current through the resistors is I and voltage across capacitor is V. Then, so here there are two situations. First, capacitor is air filled, and the second is capacitor mica filled. Suppose it is CA and it is CM. So which will be correct? Is it CA is greater than CM, or CA is less than CM, or CA is equal to CM? Which one will be correct? First, second, or third? First, you have to decide that. Which is correct? First, second, or third? Which one will be greater? CA is greater than CM, or CA is less than CM, or CA is equal to CM? Why one? You are saying CA is greater than CM. Why? Whenever you fill a capacitor with a dielectric, we know that what happens to capacitance. If capacitance in air is C naught, capacitance becomes KC naught, right? Capacitance increases. Whenever you fill any air capacitor with a dielectric, capacitance always increases. So what will be the answer for that? 1, 2, or 3? Yes, CM will be greater than CM. Because when you fill it with a dielectric, capacitance always increases. Now we have to see the current and voltage across the capacitor. So first we have to see voltage, then current. So the current through the resistor is I and voltage across capacitor is V. So we have to compare VA will be greater than VB or what. So we know that IRMS. What is IRMS? IRMS. If nothing is given, we will assume that IRMS or I. So we know that IRMS is equal to V naught. We can also say that peak value of current I naught. We know that I naught is equal to V naught by Z. and V naught by Z. What is Z? Z is R square plus XC square. What is XC? XC is 1 by omega C. You know that XC is 1 by omega C. So XC is basically inversely proportional to capacitance. So when capacitance increases, XC will decrease. Capacitance increases, it means XC will, capacitance is increasing, so XC will decrease. So XC decreases means denominator decreases, it means current will increase. So if I naught increases, so obviously current will increase. So it means this option is not correct. Current should be more when capacitor is filled with mica. And also we know that the equation of current is like I is equal to I naught sine omega t minus phi and cos phi is equal to R by Z. And we know that cos phi is R by Z. So here what happens? Z decreases, right? Here Z decreases. So it means cos phi will increase. So cos phi is Z decreases, it means cos phi will increase. It means phi will decrease. It means phi will decrease. Phi decreases means this increases and current also increases. It means current will increase, so IB will be greater than IA. So B is not the correct answer. Now what about the voltage? So we know that voltage is, what is voltage? Voltage across the capacitor is, we know that voltage across the capacitor VC will be I into XC. So and current is increasing, right? So current is increasing, we have seen that. And what is XC? XC was 1 by omega C. So C was increasing. C was increasing, so XC was decreasing. So here what happens? Current increases and this decreases. So and we have seen that current is increasing, right? We have seen that current is increasing. So when current is increases, but you know, X is also decreasing. Current is, we know that current is I naught sine omega t minus phi. Current is leading in case of, let us see, in case of capacitor, current will lead, right? So phi is decreasing. When phi is decreasing, sin phi will decrease. Here cos phi is increasing, it means sin phi will decrease. So But here, if we see current across the RC circuit, that is I naught sine omega t plus phi. Here phi is decreasing, cos phi z is increasing. We have seen that z is x is decrease, z is decreasing, right? Z is decreasing. So z is decreasing means cos phi increasing, it means phi decreasing. And here we can see that z is decreasing. So we have seen that how to decide current. Here sine omega t plus phi is decreasing and current is increasing. So but overall effect of I naught will be more. Sine omega t plus phi will have less effect. So current will increase. We will, and here x is 1 by omega c. We can also see it like that. Capacitance is increasing. When capacitance and resistance, capacitance increases, then I will put, let us discuss other question. Meanwhile, uh, I will check this and I will inform you in this class itself. So let us do another question. Meanwhile, I will check it and I will tell you to shorter way. Means in this way it will take time how to decide, because phi is increasing, one is increasing, one is decreasing. So we cannot decide easily. We can decide about current, will it will be difficult to decide about voltage. So let us see. Let us first do other question. Meanwhile, I will give you the answer for these questions. So let us attempt some questions based on JEE. Calculate answer question number 1. Meanwhile you attempt question number 1. This is JEE Main 2019 question. Till then I will do that question. Attempt this question. This is JEE Main 2019 question.
Are you doing it? Have you got any answer? So an alternating voltage is given. And an alternating voltage is applied to a purely resistive load of 50 ohm. The time taken for the current to rise from half of the peak, the time taken for the current to rise from half of the peak value to the peak value is. So we have to calculate the time only. So we can calculate the time. P is given as and for the current to rise from half of the peak value to peak value. Suppose this is point A, right? This is the peak value point B. So you have to calculate the time from A to B, right? So we know that from 0 to like C, the time taken is T. So 0 to T by 2, sorry, time period half. So 0 to this 0 to B, time taken from 0 to B, what will be that? 1 by 4 of time period. And we can calculate the time taken in moving from 0 to A, right? How to calculate? V is given. So here we can put the value 220 sine I don't know the answer for one. Yes, it is D. How you have calculated? How have you calculated? 220 by 5. So try it as homework. I don't understand how you did it. So match with it. First, what you do is you try it in this method also. Try it as the homework. What you should do is you put here sine 100 sine 100 pi t. It is. There is a printing mistake. This should be pi. So what we can do, first put v is equal to v by 2, 220 sine 100 pi by pi t, t1. So here you will get t1. So 220 by 2 will be equal to 200 sine 100 pi t. So from here you will get it like sine 100 pi t will be equal to half, and that is sine pi by 6. Sine 30 is half. So from here you will get 100 pi t. 100 pi t1 is equal to pi by 6. So from here you will get t1 is equal to pi by, sorry, you will get t1 is equal to 1 by 600 second. Similarly, so this is the time taken from when going from 0 to A. So, and we know the time taken in moving from O to B. What is that? Time O to B is T by 2. 0 to B, that is T by 2. And what is time period? T is equal to 2 pi by omega by 2. So 2 pi by omega is 100 pi. So 100 pi by 2. So from here we will get 1 by 100. 1 by 100. So now what we have to do, we have to subtract. So to get the time, what we have to do, we have to subtract 1 by 100 minus 1 by 600. We'll get it as 600. That is 6 minus 1. So 5 by 600. So you will get it as so from this you will get, I think, that one.